This is 4.4 solving equations. Today students will be able to solve equations by using inverse operations and checking answers by substitution. It should be pretty clear. Every example and all of the work that I'm showing you here gets written into your notes. We're going to look at a couple of special cases for solving one-step equations before we move forward. First special case is when you have a fraction being multiplied by a value here. So this isn't your typical problem because as we've looked at these, we've said, okay, if I plugged in a value for x, I would multiply. Technically, the opposite would be to divide. But in this case, when you are multiplying by a fraction, the opposite is to multiply by the reciprocal. That word reciprocal we talked about early on in the year. For example, if I have 2 out of 5, the reciprocal would be 5 over 2. If I had a whole number, if I had the number 4, the reciprocal, I can think of that as 4 over 1, would be 1 over 4. And so in order to solve this problem, I'm going to multiply by the reciprocal. I have 2/3, and so I'm going to multiply by the opposite, and I'm going to do that on both sides. Notice how I'm lining it up with the 18. I'm going to put 18 over a 1. On the left-hand side, 3 times 2 is 6, 2 times 3 is 6, and 6 over 6 cancels out. So I'm left with x is equal to, as I look at this, I could do this two ways. I could think 18 times 3, which is going to give 54, and then 1 times 2 is 2. And then from there, I could go 54 divided by 2, and I would get x equals 27. Now, a second way of thinking about that, I could back myself up. Before I multiply straight across, I can look at my fractions in the top and the bottom. I see that 18 and 2 can both be divided by 2. And so I'm going to do that right away. That gives me 9 and 1. 9 times 3 is 27. 1 times 1 is 1. So 27 over 1 would be 27. But I have to check my work. So I'm going to check it by plugging it back in. My equation was 2/3 times x equals 18. X was 27. I'm going to put that as 27 over 1. And then here again, I can simplify. Divide by 3. Divide by 3. 2 times 9 is 18 over 1. And 18 is equal to 18, so my answer is correct. A second special case, which is quick and easy, is if I have negative x equals 17. This right here is very much like having negative 1 times x. And so in order to undo that, it says negative 1 times x. I'm going to divide by negative 1 on both sides, giving me positive x equals negative 17. Notice that all it does is changes the sign. It was a positive 17, now it's a negative 17. If I had negative x equals negative 15, again, I could divide by negative 1 on both sides, becoming positive x and positive 15. Again, all it did was change the sign of my final outcome there. The last special case that I have for you is when you have a double negative. We want to take those and get rid of that double negative. And so I can think of that, I can use keep, change, change. And so if I keep the x, I change that to a plus, I change the sign of the 11, so that now becomes a positive 11. X plus 11 equals 16, and you can solve that from there. Give yourself a subtitle in your notes, Solving Two-Step Equations. So now what we're going to look at is a handful of two-step equations. These problems have not just one step, but two steps. Who knew? So as you look at this, again, you want to think, what would I do if I had a value for x? Okay, so let's say I had a value to plug in. If I put a value in here, first it would multiply, and then we would add. And so what I'm going to do is the opposite of those things. I'm going to first, instead of add, subtract, and then I'm going to divide. But since I have that 1/2, it's a special type of change. So the 5 was being added to whatever my answer was, so I'm going to subtract 5, and whatever I do to one side, I do to the other. This is exactly how your work should be shown. I take 5 away, over here, and it gives me 22. On the other side, the left side, I still have 1/2 x. Now, this is that special fraction situation, and so I'm going to multiply by the reciprocal. I do that on both sides. And so this becomes 2 over 2x, but those go away. Those make 1x. And then 22 times 2 is 44. It is the expectation that you check your work. If you check it and you get a different answer on both sides, that tells you what you got for your answer is wrong. So 1/2 times x was 44, plus 5 should equal 27. That gives me 44 over 2 plus 5 equals 27. Notice I'm following the order of operations now. I'm multiplying, then I'm going to add. This gives me 22 plus 5. And that makes 27, which is equal to 27. I know that my answer of 44 is correct. The last two-step equation we are going to look at today says x over 5 plus 7 equals 29. In this case, if I had a value for x, I would plug it in, divide by 5, and then add 7. So I would divide, then I would add. So I'm going to do the opposite of those two things, and I'm going to go backwards. So first I'm going to subtract, and then I'm going to multiply. So I'm going to subtract 7 on both sides, giving me 22 on the right, leaving me with x divided by 5 on the left. And then I'm going to multiply. I was dividing by 5, so I'm multiplying by 5. Those two go away, giving me x equals 110. I still need to check that my answer is correct. And so I'm going to put in 110 over 5 plus 7 and see if that comes out to be 29. I first need to divide because I'm following the order of operations. When I check, I'm using PEMDAS. And so 110 divided by 5, that gives me 2. And 2 again. So 22 plus 7, and then 22 plus 7, 29 is the same as 29. That's the same on both sides, so my answer of 110 is correct.